In this video, we're going to focus on end behavior of a polynomial. So there are 4 possible behaviors that a polynomial can have. So sometimes you could call it a positive, even polynomial. So let's draw just a basic example of positive and even. Would look something like your basic parabola that faces up. If it's negative and even, it would behave in the same way as a parabola that's facing down. If it's positive and odd, it behaves like a cubic function that's going up. And if it is negative and odd, it behaves like a cubic function that's facing down. All right, so let's go back and focus in on each one of these and describe the end behavior of the graph. So when we say end behavior, we mean what are these ends, those arrows pointing toward? And what they are doing is they're always pointing toward quadrants. So we in math have 4 quadrants that you've heard about for a long time now. We have the first quadrant where x is positive and y is positive. We have the second quadrant where x is negative and y is positive. We have the third quadrant where both are negative. And we have the fourth quadrant over here where x is positive and y is negative. So notice the ends of this graph are pointing toward the first and the second quadrant. And an easy way to remember your quadrants is they're ordered in a way that forms the letter C. So first, second, third, fourth goes around your graph like the letter C. Just a little tidbit there. So the end behavior for this graph, we would say as x approaches with a little arrow pointing to the side, as x approaches positive infinity, y also approaches positive infinity because it's pointing toward that first quadrant, and that's what x and y behave like in that quadrant. For the second end of our graph, and it doesn't really matter which order you put these, so I'm just going to write this one down next. I would say as x approaches, so using a little arrow means the word approaches, negative infinity, y approaches positive infinity. And again, it's because it's pointing toward that second quadrant where x is always negative and y is always positive. But we do need to write it in this formal notation to indicate our end behavior. So we don't just want to say negative, positive, for example. You want to write it out a little more formal than that. But it helps to think of your quadrants to make it easy to pick out the end behavior. So let's do this one. So this one's pointing toward 1, 2, looks like the third quadrant and the fourth quadrant. So the fourth quadrant is where x is positive because you go to the right in order to get there. And the y is negative because you went down in order to get there. So we would say as x approaches positive infinity, y is approaching negative infinity. That's how that end of our graph is behaving. And on the other end of our graph, we have the third quadrant is where it's pointing toward, where both x and y are pointing toward negative infinity. That's where they're headed. So we would say as x approaches negative infinity, y also is approaching negative infinity. And again, it's important to practice writing it out in this way, but use your knowledge of your quadrants to make it easy. Okay, let's look at the other 2 examples. So what if we have an odd function? So if we have an odd function, it's actually facing, and it's positive. That means it's going overall in an upwards direction. This one's facing the first quadrant and the third quadrant. In the first quadrant, both are positive. And in the third quadrant, x and y are both negative. So we would say as x approaches positive infinity, y is also approaching positive infinity. That's how that end of your graph is behaving. And this other end of our graph is behaving as x approaches negative infinity, y is also approaching negative infinity. So again, practice writing in this notation and think of your quadrants to make it easy for yourself. And let's look at the last example. If we have a negative odd function, so notice this one's negative because it's going overall in a downward trend. And an odd function, no matter what type of odd function, will always behave in this way. This is just our smallest odd function, which is a cubic function. So actually a linear function would also behave this way, so I take that back. So we have this one is pointing toward the second quadrant where x is negative and y is positive, and it's pointing toward the fourth quadrant where x is positive and y is negative. So we would just write it out as x approaches negative infinity, y approaches positive infinity. And on this end, as x approaches positive infinity, y is approaching negative infinity. Now, let's talk just a minute about even versus odd and positive versus negative. So if we, let's see, I think I have these examples right here. Okay, so what you want to think about is when you have an even function, let me come back up here. Notice our even functions behave the same way on both ends. So in my first example, both ends are facing up. So visually, I know this is an even function because both ends are facing up. Or both ends are facing down. So therefore, I know it's even. Notice positive, like we've talked about before, faces up, and negative faces down. So notice for an odd function, it's behaving differently on the ends. One end is facing down, and the other end, let me highlight those. So one end is facing down, and the other end is facing up. So this is an odd function. But overall, this graph looks like it's rising from left to right, which makes it positive. For the negative odd function, so notice the ends of the graph are behaving differently, which makes it odd. One end is facing up and one end is facing down. And then it's negative because overall it's trending in a downward direction from left to right. So it has that curve in the middle, but it's overall facing down. All right. So let's look at some examples over here for just a minute. So this is on another page in your packet. For each graph below, describe the end behavior, determine whether it represents an odd degree or even degree polynomial function, and state the number of real zeros. So I'm going to do 3, and then I want you to try the other 3. Okay, so in this first graph, I can tell that it's going down on both ends. So therefore, I know it's even. Overall, the whole graph is facing down, so I also know that this is a negative function. I know it's even because the ends are behaving in the same way. And then it has 2 x-intercepts, which means I have 2 real zeros or roots. I'm going to write it all down. So 2 x-intercepts, which are zeros or roots. They're all called the same thing, but they're real because they actually do touch the x-axis. All right, let's look at this next example. So for this one, I can tell that this one is odd because the ends are behaving differently. One is facing down and one is facing up. I can tell overall this graph is rising from left to right, so I know it's positive. And then I can tell it has 1 real root or 0 because it has 1 x-intercept. We'll just put all 3. Okay, and let's do one more, and then you try a few on your own. So let's try this one. I can tell that this graph is odd because it's behaving differently on the ends. One is going up and one is going down. So it's an odd function. I can tell overall it's going up from left to right, so it is positive. And then we can count the number of x-intercepts to determine the number of real zeros. So we have 1, 2, 3, 4, 5. 5, that's a lot. So 5 real roots, which are zeros, which are x-intercepts. So I'm not sure in these examples if we gave you one like this. Nope. But if you ever see a graph, let me just add one here. If you see a graph that has a function that comes down and touches the x-axis, and turns around, it's important that you know that that right there is a double root. So if it ever turns around at the x-axis, it's a double root. Okay, so that's it for these notes.